everyone, and welcome to today's Django Bulgaria Meetup. Time flies, as they say, and today is our last gathering for this year. Today's topic, building a simple serverless Python application on AWS, is focused on Python, but I hope it will be useful for all of you. We are streaming the event on the Hopin platform for the 6th consecutive time, thanks to our partners and friends from Launchee. Thank you guys, you are the best. And if you are joining just now, welcome to the 6th online meetup of the Django Bulgaria user group. A recorded version of this event will be available on our YouTube channel, on the Hack Bulgaria YouTube channel in a few days. Now I want to introduce to you today's speaker, Ventsislav Tashev. Ventsi is a full-stack developer at Hacksoft who uses Python and Django, a regular speaker at our meetups and other prominent events. If you have any questions during his talk, please drop them in the chat on your right. He will answer them during his talk. So now, Ventsi, it's your turn.
Thanks, Tony. Hi, everyone. I'm Ventsi, and today we will build a simple serverless Python application on AWS. So I think we can get started. So a quick one about me. I'm a software developer at Hacksoft, as Tony mentioned. I love Python and Django, and I use them every single day. And I'm also interested in cloud computing, and especially cloud computing using Amazon Web Services or AWS. So let's start with our application flow, what we'll actually build in today's workshop. So I have a few disclaimers before starting with this. If you are not familiar with any of the services that I'll mention that are here on the picture in AWS, don't worry. I'll try to explain them as simple as possible when we are building our application. So starting with our client, he or she will make a request to our endpoint. So if you are familiar with REST terminology, and I hope you are, endpoints are just regular REST endpoints that we'll define, but using Amazon API Gateway service. So our endpoint will be cars. We'll be using cars as our entity for today's presentation. So the client will make a GET request to our endpoint. Then this request will be forwarded to Amazon API Gateway, which will invoke a Lambda function. If you do not know what Lambda is, I'll explain it when we reach this step in the presentation. So our Lambda function, what it will do actually is that it will list cars, and it will list cars from an S3 bucket that we will also create. This is actually the first thing that we'll create. This is our cars bucket where we'll store our cars as a JSON file. So this is the main flow of the application, and we have actually two other AWS services that we use. The first one is AWS IAM, or Identity and Access Management Service. This service actually gives Lambda the permissions to access other AWS services, which in this case are S3 and the AWS Systems Manager, or SSM, where we'll store our data in order for it to be safe and kept in a safe place. So let's start with our S3 bucket. The most simple thing that we do, we'll just create a bucket and we'll upload our JSON data. So here I am in the AWS Management Console, and I'll go to S3 here. Just before I do anything, can you tell me, guys, whether the font size of the browser is okay, or I should zoom it? I suppose I can zoom it a few times in order to be I don't know, good to look at. Can someone just write in the chat whether this, for example, or this is okay? That's better. I hope. Maybe. Okay, I'll zoom it in, what is this, 150%? Okay, I hope that's fine. So we'll create our bucket. We click on create bucket, and here we are in the create bucket form. So we just need to give our bucket a name. One thing to mention here is that bucket names should be unique globally. It means that it should be only there should be only one bucket with this name in the whole AWS cloud. So I think we can just write cars bucket Django Meetup. I hope this is not already used. I will leave this in this region that I'm at currently. Now, all of the other settings, for example, block all public access, I'll leave this as is because we do not want to expose our bucket to the internet. We want it to be public, and we'll actually access it only through the Lambda function that we'll define later on, as you saw on the diagram. So we leave this checked. So this means our bucket is private and is not accessible through the internet now. We'll leave all of these as they are, and we just click create bucket. I hope this name is not used. Okay, it's not. So I have my bucket, and if I go to it, I need to upload my file. So I click upload. And before I upload it, I just want to show you guys what the file looks like. So this is our JSON file that we use for our cars. So the JSON file is just a root JSON object with a cars key, where cars is just an array of cars, where each car is just an object with ID, body type, brand, model, and year of manufacturing. So we have 1, 2, 3. We have 4 cars that we'll use for this demo. So I'll just minify this into a single line, and now I will come and upload it in my S3 bucket. So I come here at files and select my cars JSON file. So I click here and just click upload. So you see that everything was successful, so we can click exit. And now we have a JSON bucket, cars bucket Django Meetup, and we have a single file there, which is cars.json. And I just want to show you that this file isn't actually accessible through the internet. Here is our object URL. And if we try to open it, you see that we receive access denied because the access to our bucket is blocked. Even if I try to list objects in the bucket, I'll also be blocked. So we are sure that the access to the bucket is now blocked and is not accessible. So back to the presentation. Let me see if there are any questions before we go forward. But yeah. So we have one question. What do you prefer for JSON keys casing, snake case or camel case? Well, I think it depends on what you use the JSON for, but I think the standard requires you to use camel case because it's after all it's JavaScript object notation. So I think camel case is the preferred case, but in some cases there are snake cased JSONs. So back to the presentation, what we have done is actually we created our cars S3 bucket, but now it just lives on its own and we do not do anything with it. So we proceed forward and we'll actually create our API gateway, which is this part of the application. And we'll just create an API with a mock response endpoint, which I'll explain in a few seconds what is actually a mock response. So back to the AWS console, I leave the S3 menu and I go to API Gateway. So it loads. Okay, so here we are in the Amazon API Gateway dashboard homepage. So we have a few API types that we can create in API Gateway. I won't go into detail for every one of them, but as I mentioned, we'll use a REST API. So I'll create, just click build on REST API. So I click build, and now you see a welcome dialog. I'll close this. So we have a few types of APIs that we can create when we create a new REST API. So we have an example API, which is predefined for us, but we do not need that currently. We can import it from Swagger or OpenAPI 3, but we'll just create a new API. So when you click new API, I just need to give my API a name. So I just write cars API and leave these as they are and click create API. Hope I can zoom this to a little bit. So now you see that I have just a cars API, and here there are the resources. And we have a root, which is our root resource. This is the ID of the root resource. But as I mentioned, and as you saw, we were building an API for cars. So now I want to introduce you to the two types of entities that you can create in API Gateway, the two main ones, and they are methods and a resource. So a resource is, in our case, cars is the resource. Car is the resource for our API, and methods is just an HTTP method, get, post, put, whatever. So we'll start by creating our resource, which I need to give a resource name. So I'll write cars. So we have a /cars root, which is defined already for us when we create the resource. I won't enable cross-origin resource sharing because I won't need it for this demo. So I'll select cars and just click create resource. So you see that I have my cars resource here, and you see that I have no methods defined for this resource. So I need to define a method for this endpoint. And now I can come here, and as we'll be listing cars, this is a HTTP GET request. So we'll just create a GET method for this resource. And now if I open the GET setup, I need to configure what the integration point of this method is. So I have a few options here. You see that I have a Lambda function, which is pre-selected, which we'll use later on. So this means when I perform a GET request to my resource path, API Gateway will invoke a Lambda function. So this is what we'll do, but we'll do later on. We have HTTP, mock, AWS service, and Ventsi link. I won't go into details of these ones because we won't need them, but I actually will select mock. So you see that everything disappeared because what mock actually does is that we tell API Gateway to return a hard-coded response when we make a request to this endpoint. So we just click mock and save it. And what we have now is actually a diagram of the request flow once it's generated. Yep. So here you see that we have a method execution diagram. So we have our client on the left, which makes a request, which is defined as a method request, which is the request to API Gateway. And then API Gateway makes the request to whatever the integration type is, in our case, mock. So this is an integration request. And then this integration request is the actual backend, which in this case with the mock, there is no real backend actually. We have just a mock endpoint here on the right-hand side. And then this integration returns a response, which is the integration response. And then this is returned back through method response back to the client. So if I come here and click test, so this is the console where I can actually test my API. I can give query strings and headers, but I'll leave them empty because I don't need them now. And if I click test, you see that the request to our cars endpoint actually returned the HTTP OK of 200. And we have just no response body header, which is content type application JSON. So I can actually make a request to this mock API now. I'll show you real quick actually how to hard code some response because now we have no data, as you saw. So we can go to integration response. So this is acting as our backend now. And I have actually a predefined response for the HTTP 200 status. And if I expand this and go to mapping templates, and I open application JSON, you see that this is empty. But if I fill key value, for example, just some valid JSON, and I click save, this is actually the predefined JSON response for each GET request. So now if I come back to method execution, click test again, yep, you see that we have actually key value returned. So this is just our mock endpoint, but we do not have it currently as a URL that we can type in here in the browser. In order to do that, we need to actually deploy our API. So what API deploying is that currently this API exists, but it's not accessible through the internet. It's only accessible through this console interface. So I need to create a stage where I want to deploy my API. You can imagine this in a real case scenario where you have, for example, tests, you have staging, you have production stages, and you want to deploy each stage separately. So this is already done for you in the API Gateway service. So for our case, I'll just type in tests as a stage name, click deploy. And what it will actually do is that it will expose an invoke URL for our API that we can access. So if I open this in a new tab, and here you see that we have the DNS of the expose API, and then we have / and the name of the stage actually, which is test, and then we need to give our API the resource that we want to access, which in our case is cars. So if I type in cars, click enter, and you see that we have our key value returned back. So this is actually creating an API with a mock response endpoint. So if you guys have any questions until now, you can ask them in the chat. I'll wait a few seconds before that. So I think there are not questions up until now. I'll wait a few more seconds. And actually, as I want to mention again, if you have any questions during this demo, you can feel free to write them directly in the chat. I'll look at them once I finish each step of the workshop. So I think there are no questions currently, so I'll proceed forward. So we created our API gateway, and what we have now is actually a cars endpoint, which is publicly accessible by the client, which is our browser in this case. We have the cars endpoint, which is part of Amazon API Gateway. It's exposed to Amazon API Gateway, and it currently returns just a hard-coded response. It does not hit any backend, and especially a Lambda function that we use. And you remember that we have our S3 bucket, which is currently living there alone. So we need to map this. We need to link those two, S3 and Amazon API Gateway, through our Lambda function. So what we'll do next is that we'll create our Lambda function. Now comes the interesting part. We'll create a Lambda function, which is written in Python, because Lambda supports the Python runtime. So we'll just create a default Lambda function with a hard-coded response, and we'll map it to the API gateway later on. So I'll go back to, I'll leave this here. I leave API gateway, and I go to Lambda. So as I mentioned in the beginning, if you do not know what Lambda is AWS service which allows you to define serverless functions that can be executed without any backend. You do not care about managing servers, managing runtimes, and whatever. You can just create a pure function, and by creating it, you can select a runtime, which, for example, it can be Node.js, Java, Go, .NET Core, Python, Ruby, and a few different versions of these runtimes. But we use the latest, so we use Python 3.8. And what you can do is that you can create a function from scratch. You can use a blueprint for your function. You can use a container image, or you can browse the serverless app repository, which is actually a repository when everyone can publish their Lambda functions, and you can reuse them. So this is very useful. But we create our from scratch, and we just need to give our function a name. So as I showed you in the diagram, it will be list cars. This is the name of the function. And when you come here to permissions, actually what Lambda does is it creates a default execution role for your Lambda function. If you're not familiar with roles and policies in AWS, I'll try to explain them later on when we use IAM, or Identity and Access Management Service, in order to give Lambda permission to access other AWS services. But we have a default execution role, which is automatically created for us. You can see that here it says Lambda will create an execution role named list cars -row -some ID. And it will give permission to upload logs to Amazon CloudWatch logs. So I won't go into detail what Amazon CloudWatch is, but you can imagine that this role gives Lambda permissions to write logs in another AWS service, because we need Lambda to be able to write logs somewhere, and this place is Amazon CloudWatch logs. So we just leave this as is, create a new role with Lambda basic permissions, and later on we will modify this role in order to give Lambda access to S3 and SSM, but this will be later on. So we create our list cars function with Python 3.8 runtime and the default execution role. And I come here and click create function. I wait Lambda to create all of the things that it needs to create when creating a Lambda function. Now you see that we have our list cars function, and here on the bottom we have actually an editor for our Lambda function, which is in Python, which is good. So you see that we have we import the JSON library, and then we have a Lambda handler function with 2 arguments, which are event and context. So Lambda has 1 entry point when being invoked. So this entry point, in this case, is our Lambda handler. So if we rename this function to, for example, main, we need to change this in here, which is Lambda function.Lambda handler. So this is the name of the file, and this is the name of the handler. This is how Lambda actually decides which function to call when it's executed. So you can define your own functions here, which are different, but after all, Lambda will hit this handler function, and this code here will be executed. So just something to have in mind. So now I have my Lambda function. You see that the Lambda handler just returns a dict with 2 keys, which are status code 200, and a body, which is just the JSON version of the string hello from Lambda. So if I just deploy this function, one more thing to mention, every time you change your Lambda function call, for example, I add another comment here. If you want these changes to be applied, you need to deploy your function every single time. So I deploy my function, and now I want to test it. So I come here and configure a test event. I remove all of these. I'll just leave this empty and select my event to be test. This is just, imagine this as test cases for your Django project, for example. This is the same thing. So you create a test, and when you click test, you see that our execution result is succeeded. And if you expand this, you see that the response is actually what is written here. So we have our status code and our body. So these logs here, and this is actually what Lambda writes to Amazon CloudWatch, if you remember from the previous step. So now we have our Lambda function, and it just returns a hard-coded response, and we are good to go from here. So back to the presentation. And if you go to the flow, you see now we have our client, our endpoint with a cars endpoint, Amazon API Gateway. We have our Lambda function, but it's not yet linked to the Amazon API Gateway, which we'll do in a few seconds. And we have our S3 bucket. So we have everything set up and ready, but these three services are not linked yet. So we'll start linking them one by one. So let me see if there are any questions before that. So I have one question. Would you recommend any frameworks platforms for managing Lambda functions and related services? Yes, but it depends on what you actually want to, how you want to manage them, because there are, for example, oh yeah, you manage serverless.com. Yes, serverless is one of the platforms that you can use. It's great. I've used it, and especially for Lambda functions, and it's I think it's great. And two other serverless approaches. The first one is, of course, Terraform. You can use it to manage your AWS infrastructure, and especially your Lambda functions. I've also used Terraform for this, and it's pretty awesome. So you can give it a try if you haven't. And another thing is that actually AWS already have a service for this, and this is Amazon CloudFormation. So you can imagine this, it's the same as serverless, but it uses a bit more different syntax, but it's the same thing. But it's actually defined in the AWS cloud, and you can use it from there without any external services, as serverless is, for example. But these are the two alternatives that I can recommend, and I have used. There are others, for example, but these are the ones that I've used, and I think they're great. One more question we have: why Python 3.8? Actually, it doesn't matter for this presentation specifically. Actually, Lambda supports 3.8, 3.7, 3.6, I think, and actually Python 2.7. So it depends on what version you need. If you need to use a specific version for Lambda, you can do it. But I've just used the latest one. Serverless.com actually is wrapping the CloudFormation. I think it's wrapping CloudFormation, but you can use serverless for example, Google Cloud Platform, if I'm not mistaken. So yeah, it wraps CloudFormation, but it can wrap another other CloudFormation alternatives outside of AWS. So I'll continue with the demo. So what we have now is API Gateway with an endpoint, bucket, and a Lambda, but they're not linked. So we'll continue by linking our API Gateway with our Lambda function. So if I go back here, I'll leave this as is for now. If I go back to API Gateway, and if you remember, when we set up the API, we had a few integration types that we can select. So we have mock, HTTP, VPC link, another AWS service, and we have a Lambda function. So what we do now is that we will change our mock hard-coded response. If I go to the get method of our cars resource and go to integration request, which we configured when we set up the API for the first time, you can see that here on integration type, we can actually select the Lambda function. So once we select Lambda function, I need to provide the region that my Lambda function is living in. So this is EU Central 1, where I defined it. And my Lambda function is list cars. So you see that it's auto-completed for me. So API Gateway found this Lambda function. And one thing I need to check here is this checkbox, use Lambda proxy integration. So what here is a little helper in order to see what this will actually do. But this means that whatever headers or query parameters or request data I pass to my API, it will be just proxied to my Lambda function. So whatever I type in as headers, it will be forwarded as headers in my Lambda function. Whatever I type as query parameters will be forwarded as query string parameters in the Lambda function, as you see later on. So I check this and I click save. So here I have a confirmation dialog, whether do I want to switch. I click OK. And now, if I wait for it to spin up, yep. So you see that now our integration request of our type of integration request is Lambda proxy. So if I come here and test, and I click test, you see that I actually receive hello from Lambda, which is the response defined in our Lambda function. So we successfully linked Lambda with API Gateway. But one more thing that I need to do here is that I'm testing this through the tests interface. But if I come back to the URL where I have key value, and if I refresh, I don't know why it's taking up that much time. Well, okay, but what I wanted to show is that it actually needs to return key value again, and in order to roll this functionality, we need to deploy our API again. So we select our test stage that we defined, we deploy the API. And now if I open my test endpoint, and if I type in cars, I'm actually not sure why this is so slow. My connection is good, but it's not from us. Maybe something with AWS Cloud. So let me just check. Do you guys hear me well? Just to make sure that my connection is good. So if you just can type in the chat whether everything's fine. Sorry for interrupting, but I just want to make sure everything's flowing good. Oh, so it loaded finally. So now if I refresh it, okay, it's now faster, way faster. So it may be something with the AWS Cloud. So you see that actually we have hello from Lambda when we hit our public API. So we are good to go, and we have successfully linked our API gateway with our list cars Lambda function. So now this part of the diagram here is actually done. So we have our endpoint in API gateway, and we make a request. API gateway invokes our Lambda function. So the next thing that we'll do is actually go a little bit into IAM, or Identity and Access Management Service, and we'll give Lambda permissions to access S3. So if I go back to my AWS console, this is good for now. And I go back to Lambda. So before going to IAM, we'll write some code in order to access S3 through the Lambda. And how we can do that is actually we can benefit from the Boto3 library. If you haven't used it, Boto3 is the official AWS SDK for Python, from where you can access all AWS services that you have from your, for example, Lambda function, but from your Python code in general. So I'll just import Boto3. If you wonder whether it is installed, because I haven't installed it anywhere, I don't have a virtual environment currently. Yes, I do not have, and I haven't installed it, but it is pre-installed for us because it's the official AWS SDK, and we have it in AWS Lambda by default. So we import Boto3, and what we'll do is just create the S3 client. So this is Boto3.client to S3, and we just need to give a region, which I'll define here. So AWS region, and this is EU Central 1. So I come here, pass my AWS region, and if I save it and I just try to, for example, return, I'll just use objects, and I'll just use the S3 list objects function. So the list objects function of the S3 client of Boto3 will just try to return all objects in my bucket. So the arguments I need to give to list objects is actually my bucket name. So bucket here is, let me just define my, oops, not here. So bucket name. So if you remember, our bucket name was cars bucket Django Meetup. So if I come here and provide this bucket name here, and I'll just print them for now, print objects. I deploy my API, and if I come here and click tests, you see that it's actually slower at first, but the important thing is that it returned an error, which is access denied, because when we call list objects, we do not have permissions to do so. So if you remember, we created a default role for our Lambda function, and it has access to Amazon CloudWatch, but it doesn't have access to AWS S3, and especially our bucket. So I need to go to the AWS IAM service. And if I come here and go to roles, just waiting for it to load. So yeah, we have roles here, and I'll zoom a little bit. And here we have our list cars role that got automatically created by Lambda. So I'll open it. And here in permission policies, I need to attach a policy to this role in order for my Lambda to be able to access S3 in this case. So I come here, we have a list of predefined policies for the whole AWS cloud. So we have 628 policies already defined. And we have S3 policies. And what I want is actually Amazon S3 read-only access. So I check this, click attach policy, and this is everything I need to do. Just a disclaimer: this actually gives my Lambda permissions to get and list objects from all AWS buckets in my AWS account. So this is not currently restricted to our bucket, but for demo purposes, I'll just leave this as it is. But just have in mind that you may need to restrict this resource not to be all resources in S3, but your specific bucket. So if I go back to my Lambda, and if I click test again, you see that it passed. It returned the same response, but if you remember, we printed our list objects result. So you see that it's printed here. And we also have contents where we have our JSON, our cars JSON file, but only as a name. So we actually successfully allowed Lambda to access S3. And now, if I come back here on the presentation, you see that we actually linked our Lambda with the cars bucket, but now it just calls list objects and it does not do anything else. But what we want to do actually is we want to have our function as a backend, acting as a backend. So what we'll do is, and we also want to access our cars JSON file and its contents inside it. So instead of using list objects, I'll use SelectObjectContent, which is a function exposed by Boto3, which allows us to perform queries over certain objects in an S3 bucket. So I'll just start by giving a key here, which is actually our file name. So I'll come here and just write file name to be my cars JSON. So SelectObjectContent needs to know what type of expression you want to run over your object. So in this case, I'll just define this as expression and leave this empty for now. And the most interesting thing here is that you can give an expression type. And expression type can be a few things, but it can be actually SQL. So if you are familiar with SQL, you know that you can perform some select queries with filtration, with where, ordering. And everything that SQL supports as a language, you can use it in order to query data from your object in S3, which is really powerful, and I'll show you how it's used. Now we'll just select everything from my file. So my expression will be select star from, and typically when you use SQL, here you need to provide a table name from where you want to query your data. But here we do not have a table. We do not have actually a database at all. We have an S3 object. So what S3 already predefined for us is actually the S3 object alias. So when you type select all from select star, which means all from S3 object, it will just return all the content in your file name, which is situated in your bucket. And two more arguments that I need to provide to select object content is actually input serialization. So input serialization actually tells S3 in what format the data you query is in. So in this case, it's JSON, and this JSON is of type document. So if you remember our cars.json file, I'll actually bring it to this monitor. Let me just, yeah. So if you remember our JSON file, we actually have a root object, and there we have a key. So this is just an S3 object, and it's a valid JSON document. So if you come back here, we define our input serialization to be of type document, and we need to define our output serialization. And we just can leave this as JSON and an empty value here. So we tell S3 that our input, the data that we query is a JSON document, but the data that it will return, we want it just to be a valid JSON. So I will rename this as response, for example, and I'll just print the response here. So if I come back, deploy this, and if I test this, it should pass again. So you see that everything's fine, but what we have in the print statement here is we have some metadata about the request that actually Boto3 performed to S3 in order to fetch data. So we have the status code, the server, but the most important thing here is the payload. So the payload is actually, imagine this as an iterator. So we need to iterate this event stream from Boto and see what we have there. So if I come back to my editor, let me just close this in order to, yep, I think it's better now. So if I come here to the response and go to each event in this response, because in the response we have some events, and one of them is actually our payload from the file, the cars data that we want. So I'll just print event to see what we actually have there and how we can reach our cars data. So if I test this again and come here, you see that we actually have two events. One event is payload and another is response metadata. So we need to, oh, sorry, I need to go through the payload. I do not need the metadata. I need to iterate over the payload. So if I save this, deploy again, click test. And now in the logs, what we see is we have a record with a records key where we have a payload, which is actually our cars data from the file that we have. So, and also another metadata about how it actually performed the query, but we don't need this. We just need this records part of the event. So if I come back here and if I check whether the records key is in my events, so this means that this is my cars data. It's here. So I can just make this equal to records, which is my records from the event. And if we go here, you see that we have records, and then we have a payload, which is our cars data. So I need to access the records and then the payloads. And actually, as you saw, or if you haven't, you see that this is actually a binary string. So this is the binary data from the JSON, and we just need to decode this. Let me close this. So I can decode this in order to be an actual string representation. And I'll just define my records here because I don't have this variable yet. So I have my records, and I actually want to return them in the body and see what we got. So if we click deploy, come here, test again, you see that in our response, we have our cars data. So don't worry about these backslashes. These are just escape characters in order for this console to display valid quotes, for example, and commas. But you see that we have our cars data returned from the Lambda. And if I go back to my endpoint, I do not need to redeploy this now, the API, because it's already linked with my Lambda function. So if I come back here and refresh, you see that we have our cars data returned back from the public API that we defined. So we are good to go now. So you see that looking at the diagram, we have our client, which is our browser. We make request to the endpoint. This endpoint from API Gateway invokes our Lambda function, which actually lists cars from my S3 bucket. And before that, Lambda actually asks AWS IAM, or Identity Access Management, whether we had access to S3. So all of these are actually working together now as a single application. And we have just a few more steps before we wrap everything up. So I'll just check if there are any questions. So just check serverless. Just check serverless. Okay, what is the benefit of serverless if it runs on AWS? Thomas, I'm not sure whether you mean the serverless framework or the serverless terminologies, for example, Lambda, which does not have backend and it's serverless. If you just can, or serverless equals AWS simplified. Serverless just lets you manage your resources as a code, or the so-called infrastructure as a code. For example, Terraform or serverless.com, serverless framework. It just you can define, for example, your Lambda function as a code in a specific notation, and you can manage it later on in a version control. For example, GitHub, you can store this there and just manage them in a single place and not click on the UI that much. And another question from Alexander on resources for the policy. If you want to specify the bucket, we just need to add the name of the bucket. It's not actually the name, it's the so-called ARN of the bucket. So if you come to S3, each resource in AWS has a so-called ARN, which is Amazon resource name, which contains the name of the bucket, but it contains for example, your account ID and some specific. This is the ARN of my bucket. So it's ARN, 2 points AWS, S3, cars bucket, Django Meetup. So you need to specify this in AWS IAM role, in order to restrict this policy to access only, not all resources, but when you type the ARN here, it will be restricted to your specific bucket. So I think good to go. And okay, I'll continue with the rest of the workshop. So we linked all of these together, and if you go back to our Lambda function, oops, you see that we have some data that is actually not that related to Lambda. For example, our bucket name and file name. You can imagine this as the name of your database and the name of your table that you want to query, or the password for your database. You don't want this to be publicly accessible or just store them in a Lambda function as variables. You need them to be constants that are stored in a safe place and are encrypted and are not accessible from the outside. So in order to do that, we can use another AWS service, which is Amazon Systems Manager, or SSM. And we can store our data there in this parameter store that they expose. So if we go to the Systems Manager, you can imagine this. I won't go into further details, but you can just create your parameters and they are encrypted and stored in a safe place. So I create a new parameter. I just need to give it a name. For example, cars bucket name. And the value, it's a string, and the value of this is actually, I'll copy it from here. It's cars bucket Django Meetup. So I just paste this here and click create parameter, and we're good to go with this parameter. And we create another one, which is cars file name, and we just type cars JSON. So we have stored this in a safe place and actually in a separated space, which is Amazon Systems Manager, where you can manage all your secrets. Because if the list of secrets gets bigger and bigger, it's hard to manage. So if you can manage them in a single place, it's always a good thing. So Amazon Systems Manager is there for you. So back to our Lambda function. We want to remove these and actually fetch them from SSM. So it's the same thing here. We'll define a new client for SSM, which is a Bottletree client for SSM in my AWS region, which is the same, again, as your central one. And what I want to do is actually use SSM get parameter. And actually, I just need to provide a name. The name of my parameter that I want to get is cars bucket name. And we also want to get our file name, which is cars file name. And this will return a response, an HTTP response with a body which has parameter. And there we have the value. So we just want to fetch the value of these parameters that we get from SSM. So if I deploy this and I come back here and I click test, I want to get my parameters back. But what will happen is, if you remember, we haven't given Lambda access to SSM. So we again receive access denied exception. So I need to come back to IAM and attach another policy that will allow my Lambda function to access Systems Manager. So this is SSM read only. So I give Lambda to read from SSM, and I attach this policy. And if I come back here to my Lambda function, if I click test again, I need to redeploy this in order to work. So I just line deploy, and if I come here and click test again, you see that actually we have our data back again. So this means that we fetch some data from SSM and we provide it to SelectObjectContent to S3 with the bucket name and file name, which come from S3, and we got our data back successfully. So we have done this successfully too, and we can proceed with this. So yeah, we stored our secrets in a safe place in SSM. So we are done with actually linking Lambda with SSM, fetching some data from there, and use this data to access S3 later on via AWS IAM service in order to check whether it has certain permissions. So we finally linked all of these together. So they're all working now as a single application. You can imagine this as a single application. But what I do not like in this is that it actually returns some data from S3. And it's just that. So I come here, I refresh, and I have my data back. So I cannot do anything else. But what I want to do is actually, if I can provide, for example, a body type, and I want to filter my cars, for example, for body type hatchback, which I have here. So if I provide this, I want to get all the hatchback cars, only them, back. But we have all of them because we don't have that logic in the Lambda function. So here comes the actual power of Amazon of S3 SelectObjectContent. And you remember that we have an expression. And I can use, I actually use where statements in SQL in order to filter my data. But before we do that, I just want you to remember that when we configured our API, we marked our Lambda integration as a proxy. So this means all query parameters and, for example, body type will be passed through and to our Lambda function. And if you have query parameters, they are actually defined in the event. So I just create them as query params, and I just try to get query string parameters. This is the key that are passed in, if there are any, from the query parameters. So now I want to, if I have query parameters, actually, so let's first start with this. If I have query parameters and I have a body type in these query parameters, I want to actually make my expression look a little bit different. So I click again, select star from S3 object. But what we do now is I bring back the JSON in order to show you something. So we have our root object. So if I expand this, so we have an object. Oops. We have our root object. Then we have a cars key, and then which is an array, and then we have an object for each car. Sorry. So if I go back here, S3 selects object content to go inside of this structure. So if you remember, our S3 object is a root object. So with this notation, 2 square brackets and a star between them, you just go one level inside this data. So now I have my cars, so I can actually access .cars, and cars is now an array, and I want to actually filter based upon each object. So we use this notation again in order to go a bit more inside of the structure. And now you can imagine this as a car. So we can use the as function in SQL in order to alias this specific statement here as a single car. So in our, in our object, we have a root object with cars, which is an array, and we have each object is a car. So now we can use SQL where, and I want to filter actually if my car body type is equal to the body type that I have in my query parameters. So I need this to be in double quotes because I need to provide the value of the value that I'm filtering upon in single quotes. So I just come here and append actually query params body type, because I'm sure that I have body type in query parameters here. So it's safe to do this. And I just need to append an ending single quote. So what this will do is, if we have a body type in query parameters, I'll change the expression to be select everything from my S3 object, but for a specific car, I want to filter whether the body type is equal to my body type that I've provided in the query parameters. So if I come back again, deploy this, and come back here, I'll remove this. So you can see that everything works as it was before. So yep, we have our cars back. But if I give a body type hatchback, which I just tested, you can see that I actually got only the hatchback car that I have. So if you see all of these, you see that I have actually a coupe, a sedan, hatchback, and another sedan. So I have two sedans, and if I come back here, type body type equal to sedan, I need to get my two sedan cars back. So I have my car with ID 2, which is a sedan, and my car with ID 4, which is again a sedan. So we actually performed query string filtration based upon our cars with S3 SelectObjectContent. And just a final thing to show you, if I type in something invalid that I do not have, I'll just get an empty response, which is exactly how I want my application to behave. And if I remove it, I get all of these back. So, yep, we wired up our API, Lambda and S3, both to work together in order to filter data based on a query parameter, as now our application is a bit more useful and a bit more snappy to play with. And before we wrap up everything, I just want to mention you guys some things about optimization of this function. So if you see now, I don't know if you've seen it, but you see that our function is not that snappy. It just returns a JSON, but it's not that fast. It just takes, for example, a few hundred milliseconds. So if I come here and click test, you see that we have a duration of which the Lambda executed. And Lambda actually bills us for the time of execution. So the more the time your Lambda function is executing, the more your bill by the end of the month will be. So if we try to optimize our function a bit, we can actually make it faster and make our bill by the end of the month less. So let's see where we can optimize this. So you can see that we do not have that much of a complexity in our code, but what we have is actually these things here are actually some things. For example, the clients for Boto3 are predefined every single time the function is executed, because I mentioned that Lambda hits the handler every single time that it's invoked. So these clients are initialized every single time. So imagine this as a database connection, for example, and you open this database connection every single time, and this makes HTTP calls to external AWS services, and they are slow operations. So what if we can move these here above the handler? So it looks like nothing will change, because we just move these things here, but they are just clients. They won't change. So we can move these outside of the handler. But the important thing that we actually win here is Lambda has the so-called execution context reuse. So you can imagine that everything outside of the handler, which is the two imports, my region, and actually these clients, will be initialized only a single time if they are not already. So this is called a cold start. So the first time the Lambda executes and does not have an execution context, it will be a cold start, and this will be actually called. But the second time that you invoke this Lambda function, these these things will be actually reused from the execution context that you have. And you can imagine this as they'll be cached in the context that Lambda uses. So if I move this here and I save this and I deploy, you see that we have actually a duration of 400, around 500 milliseconds. If I come back here, test again, it should be relatively the same. So yeah, 392 milliseconds. But this is the cold start because we didn't have these variables, these constants actually in the context before. But if I test the second time, you see that okay, it took 360, but yeah, now the execution context is now used, and you see that no matter how many times I invoke this, it's around 100 milliseconds. So now my Lambda actually does not perform a connection to S3 and SSM every single time. And we can make this a little bit more faster too. So if I come here, you see that these two get parameter calls, these are my secrets. So I imagine this as these secrets need to be constant. So I can move these two outside of the handler and use them in the context we use. But we have we have pros and cons here. So context reuse is actually kept for 15 minutes. So if you invoke your Lambda within 15, if you invoke your Lambda in more than 15 minutes of time, you have a cold start. But if you call this within these 15 minutes, this context will be reused. So I can move these two, and this will take the values of the parameters in SSM. But if I if my Lambda reuses the context and I change the value in SSM, it won't be reflected here because the context is cached and these values are cached. So in order for you to make sure that Lambda uses the latest version of the parameters, you can come here and redeploy the Lambda in order to reinitialize the execution context, and it will take the correct values. So if I come here, click test again, you see now I again have a cold start. So it took around 160 milliseconds. But if I come here and test again, you see that it takes actually 10 times less than it took. So it took around 500 milliseconds, and now it takes around 50 milliseconds. It depends, but if you invoke it, you see that it's around 20, 30, 40, 50 milliseconds. It depends on the connection, but you see that it's a lot less and it's a lot more snappier to use. So you see that it's faster and it just continues to work as before. So this is the final thing I wanted to show you. So our function is actually a lot faster and will be built a lot less by the end of the month when using AWS. So I left all the resources that you need for this application in the resources in the slide, and I have a public repo in GitHub with all of for the Lambda code, the JSON file, and these slides are there, so you can go and check them out. And with this, I want to wrap up everything. Thank everyone for this, and I hope we have time for some final questions. I haven't seen them. The last questions we have in the chat. So yeah, we have one question from Alexander. Is this the same concept as GitHub secrets about the SM? Yes, you can imagine this as GitHub secrets or Heroku secrets or whatever you want to store your secrets. It's just a place where you can store them. So if you guys have any final other questions.
Ventsi, I want to thank you for this great hands-on workshop. It was really great.
Thank you. I hope it was helpful for for everyone.
While we are waiting for questions, I have one for you. How you can secure the API you've created?
Okay. Yeah. So yeah, this is a good question. Actually, if I come back to the cloud, you see that our endpoint is public and is publicly accessible. If we want to actually, oh, I'm not sharing my screen. Sorry. So come back here. So if you actually want to provide an authentication for this endpoint, you can use another AWS service, which is used for this. And this is AWS Cognito, this service. So what Cognito does is that it allows you to perform authorization and authentication for your APIs. And you can actually protect your API by using Cognito, and you can benefit from token authentication. You can benefit from OpenID, OAuth 2 protocols, and whatever authentication you want. You can implement this in Amazon Cognito and map this to your API, and then your API will be protected. So your users need to authenticate before using your endpoints. So
yes,
I hope this answers the question. Yeah, so we have some other questions. Can we deploy the Lambda to multiple zones? Currently, you need to actually replicate your Lambda, because Lambda, if I come back here, you see that Lambda lives in a certain, oh, it means zones, not regions. If you just clear out whether there are zones or regions, because you can multiply it in multiple regions, in multiple zones in your region. But if you want for it to be replicated across regions, which means around the globe, yeah, regions, multiple regions. So if you want to replicate it across multiple regions, you can use one integration of Lambda, which is called Lambda at Edge, or Lambda Edge, if you want to use it that way. So what Lambda Edge does is that you can actually, AWS replicates your Lambda all over the globe for you. And if the client is close to one region endpoint, it will access this version of the Lambda, and the latency will be a lot less. So now if I have my Lambda in EU Central 1, which is Frankfurt in Germany, but if my client is in Australia and tries to access this, it will be a lot slower because of network latency. But if you use Lambda Edge, you can benefit from that AWS will replicate this function across all regions, and it will actually make a request to the nearest endpoint that your client is next to. So I think this answers the question. Says you can deploy it, but with Lambda Edge. If you don't want to use Lambda Edge, which is related to CloudFront, I think you just need to replicate your Lambda manually, because that's what AWS does actually behind the scenes if you use Edge. So how would you use AWS Lambda in Django in a JS frontend or on several example use cases? Yeah, thank you for this question, Thomas. What I wanted to show you is that I built actually a Python backend, but with Lambda without using Django or any other framework, and that's what it's called serverless. Yeah, you can use Lambda with whatever you want. You can use it with a front end, with a backend, with everything, because Lambda actually has a invoke URL that you can invoke from whatever you want, from wherever you want. But it does not have an integration with Django specifically, because it's not meant to work that way, because it does not have a server. It's serverless. So it's I think you can call Lambda functions from your Django app, but you cannot write Django in a Lambda function. Can you use Django model in the Lambda function? No, because if you want to use Django model in a Lambda function, you need to install Django in your Lambda function. Or would you? Yeah. So if you want to actually create a model or whatever Django entity you want in a Lambda function, you need to install Django, which automatically makes your Lambda not serverless, but it cannot be not serverless. So you cannot do this with Lambda because it's just a different approach to building APIs. I hope this answers the question.
Any other questions?
Yeah, we need the database running somewhere. Yes, but if you want to run Django on AWS, you use services like EC2 or ECS in order to run Django as an application. But you cannot write Django in a Lambda because you do not have the interface to do it, and you cannot run your server, for example, or your console, whatever. The runtime is limited to bottle. Actually, it is not. What I didn't mention is actually AWS includes, for example, JSON and bottle tree and logging, I think, but I'm not sure. It's included by default because it's actually bundled this way. But if you want to, for example, install a separate library for Python, for example, if you want to install requests, you need to actually, one way to upload your Lambda code is actually writing code in the console, which I've done in this demo. But if you want to actually write your code in your editor and then upload it to Lambda, you can do that by zipping your Lambda function in a zip file. So if you want to bundle libraries too, you can zip them with pip install, and with pip install you can give a target argument, and this will actually store the libraries not in your virtual environment but in a specific folder that you provide. And if you zip your Lambda function code with your dependencies in a single zip and upload it, you can use these dependencies in Lambda. So it's not limited to bottle, but you can install whatever you want, but it's just a little bit more tricky to upload to Lambda and to use them. One more question. Can run tasks asynchronously on Lambda? Yes. It's actually another feature of Lambda. I'll go to my Lambda console. Actually, if you want to, for example, spin up 1,000 instances of your Lambda function running simultaneously, you need to configure, actually, let me just see, where is this? So yeah, we have this concurrency tab and this provisioned concurrency. So you can configure this and you can tell how many, for example, how many instances of your Lambda you want to instantiate in a single invocation. So for example, if you can tell that if I call my API, I want to spin up 100 instances of my Lambda function, and you can configure this here. But the tricky part is that it's actually, it bills you more for the concurrency that you define. But actually, if you use this concurrency the way you configure it, so if you, for example, tell Lambda to instantiate 100 instances and you use only 5 of them, you will build a lot more than the standard Lambda configuration. But if you configure 100 instances and use 100 of them, actually your build can be less than it is currently without the provisioned concurrency. So it depends on the use case, but yes, you can run Lambdas simultaneously.